And we're back. We are looking at graphing two-variable linear equations, otherwise known as coordinate geometry. Now over here we have a coordinate plane. It looks intimidating, but it's really not that big a deal. All it is a number line here, 0, 1, 2, 3, 4, 5. Down here are the negative numbers. And here's just a second number line. Right up here is positive, here's negative. Okay, so two number lines intersecting where they both are 0. Okay, not a big deal. Now you may see something that looks like this. Graph y equals 1/2 x, say, minus 3. Okay? Now if we have y equals 1/2 x minus 3, this is an example of this general linear equation format called slope-intercept form or gradient-intercept form. Okay, here is what's called the gradient or slope, depending on what part of the world you're in. Okay, and back here is what's called the y-intercept. All right, you may see it as y equals mx plus c. Doesn't matter, it's the same thing. Alrighty, so over here, our gradient or slope, of course, is the coefficient of x. It's 1 over 2. And our y-intercept, this would be plus b plus negative 3. So the y-intercept is negative 3. Okay? So what we do is we put a dot at the y-intercept. Okay? So on the y-axis, put a dot right there. Oh, wait a minute, it's negative. Not right there, right there. Okay, and then from the y-intercept, we do the gradient, we do the slope, we do what it tells us to do. And here's the idea: the top means move up, bottom means move right. Okay, top is up, bottom is right. If it's negative, the top is down, but in this case, the top is up. So this means up 1, right 2. Okay, up 1, right 2. So from here we go up 1, right 2, up 1, right 2, and we keep repeating that. It's the same thing as down 1, left 2, down 1, left 2. We keep repeating that pattern and then connect the dots, and that is our line. Okay, so we graphed y equals 1/2 x minus 3. It's always a nice idea to put the equation above the graph there. Alrighty, so now you're going to try one. Okay, we're going to go on down here, and I want you to graph y equals, I don't know, 2 over 7x plus 1. Go ahead and graph y equals 2 over 7x plus 1. Pause it, see if you can graph it on your paper. Okay, so it should look like this, right? You're at positive 1, up 2, right 7, same as down 2, left 7, connect the dots. Bam! Okay, now this is a fraction. We like it to be a fraction because it tells us to go in two different directions. If it's not a fraction, you turn it into a fraction. For example, y equals, say, I don't know, negative 3x. Okay, y equals negative 3x. The gradient is negative 3. The y-intercept is right here. What number is right there? What do you see right there? See nothing, right? Mathematical term for nothing is 0. So we start right here. Now, we need to do the slope. This is equal to what fraction? Think in your head, what fraction is that? It's negative 3 over 1, right? So that means down 3, right 1. Don't forget the right 1. That's very important. So from here we go down 3, right 1, down 3, right 1. Same as up 3, left 1, up 3, left 1. Okay, and we can connect those. Okay, so that's the idea. And what this is, just as a reminder, this is a collection of points, all the points that satisfy this equation. So if you went to this point right here, this is negative 3, negative 9. Excuse me, negative 3, positive 9, right there. Negative 3, positive 9. So if it goes through negative 3, positive 9, if we plug this in, the y is 9 times negative 3, the x is negative 3. This is true. This point, x and y, if you plug it in, make this equation true. And that's true with all these points, even the fractions or decimals in between. makes this equation true. That's what the line represents. Okay? So, let's have you try one more here. What if you try y equals x? Go ahead and pause it and graph y equals x right here, okay? So if you graph it, you can see that the slope is 1, gradient is 1, slope is 1, y-intercept is 0, goes through here, up 1, right 1, up 1, right 1, up 1, right 1, which makes sense because it goes through 5, 5, 7, 7, 9, 9, negative 4, negative 4. The x is equal to the y. Whatever the x is, the y is as well. That's what this line represents. Okay? Now sometimes your teacher or the real world is not quite so nice and they don't give it to you in this format. Okay, so sometimes you have to manipulate the equation to be able to graph it. I'm going to show you how to do that, to put it into the same format. You can also graph with intercepts as well, which I'm not going to show you. Maybe you can ask your teacher about that. But if we had something that said graph 2x minus 3y equals negative 12, okay? Now you can't just look at this and say, oh, well, I know what the slope or gradient is. I know what the y-intercept is. This isn't screaming it out at you. You have to manipulate this. If you notice, if I scroll back up here, okay, each one of these is y equals, okay? Each one of these starts with y equals, right? So down here, we need to get y by itself. We need y equals. So to get y by itself, we need to get rid of this. What's the opposite of 2x? It's minus 2x. We do that to both sides of the equal sign. These cancel out to 0. Then we have negative 3y by itself. Don't forget the negative. Can we combine these two? This has an x and this does not. No, we can't. So we write negative 2x minus 12. Negative 2x minus 12. And we write it in that format because we want the x term first. Okay? And then we want to think, what is the opposite of times negative 3? What's the opposite of times negative 3? Let's divide everything by negative 3. So we divide everything by negative 3 and we have y equals positive 2 over 3x plus 4. See how we got that? We simplify each one of these. So now this is nice and easy to graph, right? Where do we start? Yeah, we start at 4. And from there, what do? We go up 2, right 3. Okay, same as down 2, left 3. Okay, so that's the line here. That is the graph of this as well as this. Just different formats, same equation. Okay, so I'm going to give you one, and then we'll call it a day. Okay? So, how about if you graph x minus 3y equals negative 6. Okay, so go ahead and solve for y, and then graph this equation. You'll check it here. Go ahead and pause the video right now. Okay, so we have this line here. We solved for y, went to 2, up 4, right 3, connected the dots. And now you can graph linear equations, regardless of what format they're given to you. Just solve for y and go from there. I hope you learned a thing or two, and we'll see you next time. Toodles.